Okay, welcome back to Displaying Numerical Data Part 3, and this time we're looking at a type of graph known as an ogive. That's the way to pronounce it, ogive. And essentially what these graphs are good for is when we've got grouped data and we're basing this off the frequency. That's the number of scores in each group. So this is one of the situations where we don't have the original data, we just know how many things are in each group. So when we draw these, essentially in our table, in our frequency table, we've got the groups, how many things. And we've got this new thing that's called cumulative frequency. That's a new column on our frequency tables. And hopefully it won't take much for you to wrap your head around it. So cumulative sort of sounds like the word accumulate. And essentially what it is, we start in our first column with the same number as the frequency, and then we just add the next thing. So 5 plus 8 is 13. So eventually what we're going to do is we're going to be adding up how many bits of data. So eventually we're going to wind up with the total number of bits of data at the bottom. But the number tells us how many things are in this group or faster. So in this case, we're using the sprint data again. So this is times between 10 and 10.5 seconds. 10.5 seconds up to 11. So this just tells us how many bits, how many scores, how many bits of data were in this group or below or faster, depending on what the data is. So the next one would be 13 plus 14, 27. 27 plus 10 is 37, and then 37 plus 3 is 40. So we had 40 pieces of data. And so essentially if we say this was the slowest group, there were 40 athletes who ran in either the slowest group or faster. So this is just get used to doing this cumulative frequency, because an ogive is essentially, it's a histogram of the cumulative frequency data, but then we use that histogram to create a line graph. So I've already sort of set it up. Here is the histogram of this data. So the first one goes up to 5, kind of rough. It's really useful to do these on graph paper and be as accurate as you can, because the point of doing these is that we can then read stuff from the graph to get an idea of slightly more particular information about the data, even though we only know how many people are in each group. Okay, so the first one goes up to 5, the next one 13. I've just done it in green because the histogram isn't really what we're after. So once we've sort of got this idea in our head, an ogive connects this, the bottom left corner of each bar in the histogram to the top right. If I just put the dots in, so we're just going to connect all these until we get to the top. And because we're constantly adding more data, this graph is going to go all the way up. And we can say that this is 100% of the data. Later on, we're going to be looking at So that's 50% of the data. So we can use this kind of thing, but that will come later. So all I'm doing is joining these dots. There we go. So that's where the line segment part of the graph comes from. And really the Ogive is just that line. So at this point, we can get rid of all of those. So that is our actual Ogive plot. Now, these are useful in group data simply because we don't actually have our scores anymore. And we can use it to answer all sorts of questions, even though we've sort of lost our original data. So, like I said, it's important to have a regular scale going this way. Where it starts isn't quite so important, but as long as once you have the groupings, it's a regular scale going that way, and the cumulative frequency should always start at 0 and go up to the total number of scores. So this CF is the cumulative frequency. So V1.8 is asking us to use this graph, this Ogive, to answer a few questions. So the first question, A, how many athletes finished in less than 10.75 seconds? Okay, so what we would do there is we look on our scale here. 10.75 is going to be directly in the middle of 10.5 and 11. So let's just use a ruler to try and, what I'm going to do is line going up, and of course on graph paper that would be much easier, and then we can read across. So that's less than 10, so if these are 10, 1, 2, 3, 4, 5. So that's about 8 or 9. The question A, just simply reading from the graph, and of course that's why it's important to be accurate. So question A, how many athletes finished in less than 10.5 seconds? Well, it would just be 10.75, so we're going to say approximately 8 to 9. Times that, then 10.75 seconds. Part B, how many athletes took longer than 11.2 seconds? Okay, so that's 11, and that's 11.5. Let's say 11.2 is about there. I'll do the same thing, try and vertically as I can. I'll try and get that. Of course, on graph paper, this would be more accurate than what I'm doing here. So that's I'm going to say that's about 18. Call that. Call that one 9. Let's say that's 9 because it's closer to the 10 than that one. So, how many athletes took longer than 11.2 seconds? So we know there was 18 who were faster. So we're going to have to do 40 take away 18 is 30, 22. Longer than 11.2 seconds. Because we're not talking about these people, we're talking about these people because they took longer to finish the race. What fraction of athletes, so this is the third question, what fraction of athletes finished in less than 11.8 seconds? So, let's say 11.8 is there. Draw our horizontal line. I hope this is going to be pretty neat. I'm going to say that's 40 and that's 30. Maybe we'll call that 34. So 34 athletes. If you do this same example in the grid in the book, you might get slightly different numbers, but I'm going to call it 34. So what fraction of athletes finished in 11.8 seconds, less than 11.8 seconds, so that's all these people. We've got 34 out of 40, and I think we can probably reduce that fraction a little. Equals 15, 17/20ths. Athletes and 11.8 seconds. So I'm reading a number off the graph and then I'm relating it back to the actual data to answer the question. Okay, so I've got one more example. Okay, so this is our last example in the Ogive section. So this is essentially the example. The data shows the speed of 30 cars measured by a police radar gun. We've already looked at this, but we'll go through the motions again. The first thing, tally the data using a frequency distribution table. So we'll do this bit first. Then draw an Ogive of the data. So we'll work out how many bits of data are in each group. And we'll do a cumulative frequency and represent that as an Ogive over here. And then we've got some questions to answer using our Ogive graph. The first thing, let's just tally all the data. So, first one, 78, that group. 7, 6, 7, 2, 4, 5, 2, 2. So hopefully that's all the data. So now I'm just going to convert our tally marks into numbers for the frequency. 2, 5, 5, 10, 13, 6, 3, 1. So that's the amount of scores in each group. Now we're going to do the cumulative frequency. So we're going to start with 2. There's only 2 things in the smallest group, or the slowest group. 2 plus 5 is 7, plus 13 is 20, 6 is 26, plus 3 is 29, plus 1 is 30, and that is the number of bits of data we started with. So that reassures me that I haven't missed any bits of data. We haven't got anything wrong. Okay, so these are the numbers that we're going to be using to plot our growth of how many bits of data we have in ever increasing faster speed. Always label axes. Okay, so this is our first group. So our first point is going to start at 0, and then between 40 and 50 we go up to 2, which is there. So I'm just going to put dots in for now, and then we'll join them up. So the 50 group goes up to 7, so between 50 and 60, about 5, 6, 7, stay there. The 60 group, 60 up to 70, there's now 20 things in that group. A bit high. Trying to be as accurate as I can. The next group goes up to 26, 29, and then 90 up to 100. Our final 30. So I've squashed that in a little bit on the side there. Oops. There, so there's our Ogive. Tried to be as accurate as I can. I tried to keep my scale regular. Yeah, so now we've got some questions to answer. Change to green so we can draw over the top of this. So part A was complete this, part B was do that. Part C, how many of the vehicles were travelling at a speed less than 75 kilometres per hour? So, here's our scale. 75 is halfway between 70 and 80. Just put it in the dotted line. Because really, all we need is that point where it crosses the graph. So we started here, we measured up to the graph, and then we went this way, and that's 25. I'm going to say that's, oops, not 20, 22. So question C, trying to phrase it as a sentence in terms of the data. How many vehicles were travelling at a speed of 75 kilometres an hour? 22. Drivers were travelling less than 75 kilometres per hour. Oops. D. Question D. What fraction of the vehicles were travelling at a speed of less than 58 kilometers per hour. So 58 would be 55. Let's say it's about there. Across the graph about there. So my line's a little bit wonky. I'm going to say that's maybe about 6. It's slightly, it was a bit more that way. So the fraction of drivers driving less than 58 is 6 out of our total 30. And that is 1/5 drivers less than 58 kilometers per hour. Question E, how many of the vehicles were traveling at a speed more than 65? So, because we're looking at speeds above a certain amount, we're going to have to work out how many were less than, and then take that away from the total. So 65 is going to be right in the middle of those. So 10, 20, 15 is about there in the middle. Do we call that 12 or 13? Let's go 12. How many of the vehicles were travelling at a speed of... So we've got 12 vehicles were travelling at a speed less than 65. So that means all the others out of the 30 were travelling greater. So we've got to do a little subtraction. 30 take away 12, and that is 18 drivers faster than 65 kilometers an hour. And the last question, F. If police enforce a fine on all those drivers travelling over 65, how many will get the fine? Not 65, 78 kilometers an hour. So anyone going faster than 78, they'll get fined. So that was 75. I'm going to say 78 is there. Two, let's call that 24. So that means if 24 drivers were going less than this 0.78 where we get a fine, that means there were 30 take away 24, 6 drivers will get a fine. Okay, so there was a certain amount of interpretation on my part because I didn't have a more exact scale, because my lines weren't necessarily exactly 90 degrees going upwards and sideways. So it's really important to keep these ogives as accurate as possible. Be very careful with your ruler and the thickness of your pencil and reading numbers off the scales. Okay, so that's it for this section. I hope all that made sense.